is also interesting because the company is already building or has built trackers in the Northern Hemisphere. And the presenter I would like to introduce is also a very well-known and long acquaintance. We have with us Jan Vedde, who's a Senior Project Manager at European Energy. Jan has worked in silicon material science, crystal growth, PV project development, and product business development for more than 20 years. I can remember we've been already talking nearly 20 years ago if float zone could be the future way to produce high purity ingots. It didn't happen outside the research in the end for solar, but yeah, great to have Jan, who's at European Solar, which he joined in 2015, now dealing with PV project development with a focus on legal, administrative, as well as technical and commercial issues related to construction, operation, and performance assessment. So that's the topic rather of today. Not float zone or crystal growth, which is still important, especially for the large wafers we're all seeing now in big modules, but we stick to solar trackers today. Jan, happy you're here, and the floor is yours.
Yes, thank you very much. I'll try to share my screen if possible. Yeah, it should be there. Is it there? Do you see my screen?
All good, yes.
Yeah. Okay, yes, thank you for giving me this opportunity to share with you some of the experience we have collected over the years in European Energy. And the experience relates both to some basic research questions that deals with tracker gain and bifacial gain, but also some technical challenges that you'll have to face when you actually do installations. And then we also have the whole concept of selecting the right technology for the right site. So, but first a few things about European Energy. It's a Danish-based project developer. We are active in solar power, but also on onshore and offshore wind, and we have some activities also downstream with energy storage and renewable fuels and so on. So we are a typical developer. That means we are scouting for a site. We are doing the planning and obtaining the building permission, and then we will do the construction. In Denmark, we are the EPC ourselves, but in other countries, we will have external EPC partners. Then we also have an asset management department, and we may sell off some assets, and of course the in power sales divisions is very important, as this is how you today will generate your revenue by having a good PPA in place. We are active in Europe, but also in USA and Australia, at least to some extent. So we have some nice growth figures over the last years here with the equity raising by 118%, EBITDA with 82%, and we currently have 600 megawatt under construction and also a nice pipeline. We are around 200 people in the company so far. So our tracker experience started back in Spain in 2008, and I was actually with the company already at that time. So we have also done 90 megawatt in Brazil over the last years, and started out in Denmark with 2 commercial projects last year. This year we will only do something like 34 megawatt, and that's out of a total volume of more than 500 megawatt. So it has shifted a little bit. So this year we did not see the same potential for trackers in Denmark as last year, and I will try to elaborate on how this could be the case. But first I will introduce some of the research questions and research learnings we had, and that came out of a project we installed at the Technical University of Denmark, their research campus, where we had our own test site installed in 2018, exactly to study tracker gain, bifacial gain, and specific Danish conditions on irradiation and so on for bifacial modules and trackers. So this is a bird's eye view on the test site. We have something like almost 0.5 megawatt installed. Not all is here on the list. It's both single axis tracker and fixed tilt systems. We also have 2 small 1.5 axis tracker, double axis tracker, not on the picture, and also another tilted tracker and so on. This test site is equipped with the best possible measuring equipment, both with respect to solar irradiance, but also electrically, as each individual string, and in this case, a string is 22 modules, 4 of those on a tracker. They are individually measured with high precision DC current and voltage measurement. So this is our research tool, and a lot of things has been done here to study tracker gain, bifacial gain, albedo. I will not go into the research papers, which I will show you later, but some qualitative illustrations of what we can see from such studies is like this: the comparing the fixed tilt performance with a very typical noon peak with the tracker gain, which here in Denmark, this is in April, will show a dip during noon as the trackers are horizontal and the sun is still not in zenith above the trackers. So we have this midday dip with the trackers. We also see the difference between the monofacial red and the bifacial green curves. In this graph, there's no bifacial modules on the fixed tilt, but they are there also. So this is one illustration of what we can do with the test site. This is an old illustration also now on an hourly aggregation level, where we see again the mid-time dip here in profile. We see the peak of the performance of the fixed tilt, and on the bars below you see that the gains above 1 is in the morning and in afternoon, if this is the 100% line equaling fixed tilt performance. So those are the type of the investigations we have done. I would like to show also this 1.5 axis tracker, which is quite fun and definitely a very well suited concept for the Northern Hemisphere, to stick to the title of the talk. You have a performance which is much more square-like without the noon dip during this is March, April, and May, as you see. But you have the fixed tilt with a standard peak, and then a more square-like envelope of this tilted tracker, or 1.5 axis tracker. So it's definitely an interesting concept. Also, it's really annoying to have a panel laying down horizontally during noon when you have in the nice summer days. You would, and definitely also during the winter, where you do need to tilt the modules against the sun to get just something out of it. So those are I'll skip this one. Those are some of the technologies and research working tools we have had. It's a preliminary graph, this one, demonstrating how the transposition factor of the 2-axis tracker, the tilted tracker, and the horizontal tracker will look like, and the former slide showed you how the expected transposition factor for a standard fixed tilt system would be in Denmark. So that's to evaluate the tracker gain and compared to the fixed tilt transposition factor. And a lot of these things has then been published by first of all my colleague Nicholas, who has done a lot of this research at Risø. In these papers, we have studied the bifacial uplift and tracker gain and various other things. What the main conclusion from this study is that you are actually able to model the performance of bifacial modules on trackers also in an environment like the Danish, where you have a lot of diffuse light and so on. If you, as always, select the input parameters properly. It is actually quite complex to always get the right input values on maybe not on torque tube height, the rear structure shading, tracker and transparency and so on, but the rear irradiance in homogeneity is something, and albedo and impact of diffuse light is something that you also have to put into the model correctly. There's a lot of the basic information about this research test site has also been added to this PVPS report. I forgot that it has actually not been released yet, so it will not be until in 1 month or so that you can read about the research test site also in this PVPS report. So those were the basic research questions that we have to address to feel safe in installing and making yield predictions on trackers in Denmark, bifacial modules in Denmark. Then we have also been engaged or had to be dealing with a lot of more practical technical questions, not based on our own in-depth research, but rather by discussing by suppliers. And it comes back to how to select the tracker, the control strategy, or other specific applications. And like this slide will show you, it's a question how to maximize the performance. Will 1P or 2P be the most attractive solution? There are definitely a lot of inputs out there from suppliers, both like the Soltech and Nextracker and even Soltigua have provided a lot of relevant and good insight in how to evaluate these different options. And it all comes back, as we have understood, to also understanding what is the boundary condition for the installation in general. Do we have area constraints, or do we have constraints with respect to area constraints, first of all? So those are one class of problems to be discussed with suppliers. Another type of questions you have to discuss with suppliers is how to have the right control strategy, and with control strategy in this case we also seems to have to address the fact that there's a lot of diffuse light, not so much direct, and how to optimize for that. It may not be a research type of question, but how to implement a good routine and control strategy, that's the discussion point. Whether astronomical solutions, algorithms should be supplemented by some sensors, like in this case where we have worked with the small company StarTech, that have applied some extra sensors also to help us to figure out what is the optimal strategy. We have also had to look deeper into stow strategies, and that is back to also what we have heard previously, that the whole concept or the whole discussion on statics is quite important. And at least when we started out some years ago, we did not find that the documentation from some of the suppliers on the issues of statics and how they have found it pertinent to ensure that you can avoid torsional galloping and so on. That was not really to the required standard at that time. It has improved later, but we did have to dig into these issues ourselves before we were able to really work with the supplier. Then, of course, we are also looking into various agro PV applications, and these are just illustrations. But again, it's definitely something worthwhile to look into, how to adapt the technology to specific conditions or dual use conditions, which can be quite important if you want to also solve challenges with respect to land use, land taxation, and so on. And down to the left, I can show you that we actually even tried at the research test site to do some very quick and dirty crop analysis or crop growth investigations between some of the rows. So we have just started out slowly in this. So one final thing, I showed you the dip in the midday on the performance. If I now look at like this, a heat map for tracker and fixed tilt, the message should be that during the day the profile is more flat, as already seen when you saw the profile. This is a generation, but if I multiply this generation profile with the sales price, the hourly spot prices, where we do see somewhat higher prices here in the morning and in the afternoon, and a little lower here during the midday, then we get to the conclusion that there is a value factor, something like 4%, to be added to the value of tracker generated profile or energy compared to fixed tilt generated profiles. And that's even that's of course based on historical prices and in a context of the Danish electricity system, where we have totally wind dominated price settings and very limited, only 3.4% PV in the energy mix. So it's definitely not yet noon dipped prices due to solar. We are not there yet. This has also been published in an external paper. But now, for the last part, I will look into how to actually decide on which technology to use, and also what is the right tool to use when you want to decide on optimization strategies. And we see three basic concepts: the very simple CapEx or yield ratio, LCOE, but what we have been looking into also is the need to actually do a full financial model before you can do some conclusions. So first of all, it would of course be simple just to compare cost benefit, the CapEx over specific production. And in this example, I've just taken some numbers from the Danish Energy Agency's report on technology data. And by dividing the expected CapEx by the expected specific production, these are general Danish numbers for 2021 from the Energy Agency, then we will see that it's all more or less similar cost benefit numbers if I had reduced the difference between the fixed tilt and tracker, the CapEx, to a lower delta, more realistic as for today. we would end up with exactly the same cost-benefit KPI, which means that the basic starting point is justified. They are fixed tilt and trackers are equally attractive in a Danish context. So we need some other stuff to really differentiate and figure out what is the more attractive solution. Then it's obvious to look into LCOE, because here you can then also address the CapEx, the capital costs, and land use and land cost and so on. More details OPEX analysis. So it's definitely useful, but we should remind ourselves that LCOE is only the cost. It will not really help you to determine or address the true value of your project. That's different from costs. So it's useful to compare different technologies, but it's not insufficient, at least in our opinion, to be used as an investment level decision. To do so, you really do need to work with a full financial model. And in this example, I also have taken both the formula and some of the discussion points from this recently published PVPS project on LCOE and uncertainties in yield predictions and so on. So what we will suggest and work with is, this is then the final business slide, to work with a full financial model if you want to have an investment grade decision. In this case, you are able to include into the analysis, on top of all the basics used in the LCOE calculation, also things like, or parameters like, system degradation, unavailability, and curtailment. Maybe it's a curtailment that will only last for the first couple of years until the grid has been enforced. You can add more details on the power prices. It could be a mix of PPAs and merchant prices. You could add the value factor for the various technologies if you can convince the investor that this is a real value that can be captured in the market. You can add land lease details and decommissioning bonds and whatever you have to deal with in a real financial modeling. All the financial details of the depth, maturity, interest, and debt service reserve account, and all this is also part of the full financial model and important for decision making, as well as depreciation, tax, and the investor target IRR. That's actually the last part, the investor target IRR. That's how you determine what is actually the value of a project. What is more important or interesting is then the output parameters. So most people will know about IRR, which is a good measure of the return on investment, but it's a relative measure. If you want to have an absolute measure, you could go to the NPV, but still something is missing here because what is actually of interest is not the value of the project, but the profit. If you want to sell it, or if you have it evaluated by an asset owner, then you will have to look at the difference between the sales value and the total costs incurred. And that's the true measure. You could also add as a KPI the operating margin, which is then the profit over the CapEx, just to emphasize that it's also important to have an efficient use of the capital you have when you are out there earning money. So the interesting thing is that evaluating different options, and in this case, I'm talking about fixed tilt versus tracker, then you might get to different conclusions as to what is the more attractive among these two, whether you optimize for IRR, the profit, or the operating margin. So there's not one single technology solution that necessarily is the best on all parameters. So it comes from the fact that both options are attractive, but it's just a reminder that before you can really make a technology decision, you have to discuss with some senior management, they are always involved, what is actually the more important factor to optimize in a given context in the company. Do you have sufficient capital to spend on all possible projects, or do you want to save your capital for the most attractive, the highest operating margin projects, or is it just important to earn the maximum profit? So some of the balancing points that came out of this analysis, this type of analysis, is that if you have area constraints or high land costs, then it will penalize the tracker solution. Not so strange, since the trackers are better applied where you can have a decent GCR. Otherwise, you will penalize yourself. If you have grid constraints, then you might penalize the fixed tilt solutions. We have also had examples where everything else is not important. The only important thing is to fulfill a contractual obligation to deliver a certain amount of gigawatt hours. In that case, the only thing you can do, you can forget about technology optimization. You simply add as many panels to a given the site as you can fill in, if you are otherwise breaching your PPA agreement. So high power prices will favor the tracker solutions. If you have risk-averse investors, then you might go for a fixed tilt solution. That's reflected in the investor target IRR, which is then lower or higher for the tracker part. And one last comment is that by doing this integrated modeling, where you have both the technical parameters and the full financial modeling in one sheet, you can add more parameters to the uncertainty analysis. So it's not only uncertainty and the difference between P50 and P90 or whatever is not only determined by the uncertainty in horizontal irradiation or solar resource estimation, but all other parameters that you have entered into the model can be assigned an uncertainty. And based on this, you will have an expanded uncertainty analysis, which will improve your strategy or improve your potential to make a good decision. So investment decision. So in conclusion, we see that yes, tracker gains, bifacial gains can be predicted reliable by existing models if you know how to select the right parameters. That if you have limitations on grid connection or land use, you will probably see different technologies appear as a more attractive. And yeah, so to make a full investor grade decision and technology optimization, in our opinion, it's really required not only to do LCOE analysis, but also do a full financial analysis. Yes, thank you for your attention.
Thanks, Jan. Thanks for that great presentation. Really sharing with us your view on technology selection. Again, we're still running late. Please take your time and stay with us and answer questions in the chat. I've seen there are already a couple, and I'm pretty sure there will be more. Thanks again, Jan.